Okay, hello everybody. We'll be talking about dlang. So, the deep programming language, which I really like. I use it for over 20 years, and I think it deserves a little more attention from people because there's a lot of competition, and some people might think, "What is this D? Why is it dying? Is other languages are on the block like Rust and Odin, Julia, Zig?" But I would say D still rocks, and no other language can come close in many aspects to it. There are some competition. There's some competition for some cases, but D I think is still worth exploring, worth using, and has I think more universal application in many places. So what is D? D programming language, which we just call D, or when we search on the internet, we can use dlang. It's just easier to type dlang than D. It's a programming language for general usage, statically typed, and multi-paradigm. So it has multiple ways of doing the same thing. It doesn't force you to do specific style of programming. You can do functional, you can do imperative, object-oriented, message passing, template, metaprogramming, and so on. There's many ways doing the same thing, and D supports that everything, and it fits nicely. It's not like hodgepodge. You can just do what works for the job. So it's very pragmatic. The standing features are rich metaprogramming facilities. It has 4 complementing flavors of metaprogramming that also fit really nicely together. There are templates. There are a bit more. If you're familiar with C++, these are not like your C++ templates. They're very similar, but syntax is different, much more friendlier, and they're much more powerful. You can do much more with them. There you have mixins, which combine with templates to do some things that are impossible in C++, basically. Then you have code mixins, which allow you to do absolutely anything you want, including do some crazy things like implement your own polymorphism or typing, serializers, code generation, many other things, importing other languages and transforming them, so many things. And reflection, which in this case I'm talking about static reflection. There's some feature you can do some not really runtime reflection. You could use static reflection to build some data structure for dynamic reflection to work, but mostly you don't want, but because it will be pretty slow. So what you can do static reflection, and that also plays together with other things like templates mixing and code mixins to enrich your code to be more generic and metaprogramming friendly. It is, as I said, statically typed, usually compiled. Well, all the compilers compile. All the static checks are done at compile time, and then you have a binary. System level coding is possible. For example, you can do memory management, do pointer arithmetic and dereferencing, syscalls, assembly, interact with the hardware directly. So if you want to write something super high performance, or kernel or BIOS, or run it on a microcontroller, or maybe a web game, or like standard library, you can. And actually, there's a lot of also helpers to interact with C, basically seamlessly without any extra boilerplate. You can just add one line of code and call the C functions directly, no problem. It is garbage collected in a sense by default. It's not a feature of the language per se. There are a few operators that kind of implicitly use GC, but you don't need to do these operators in a generic code, so you can actually you code in D without garbage collector. The as an example of system level coding is that the garbage collector implementation in D runtime is written in the D itself. So that's pretty nice. Also, compiler is implemented in D, so you can do pretty complex applications. Initially, it was in C++, but then it was ported to D, and it makes sense. So it has a very similar syntax to C, of course, or C++, or if you know other languages similar to them, like Java or C#, that you'll be familiar, right? Something like this. Sure. Or have some variables and so on. So we'll get to that in a moment, of course, but it is not like Python, or it's not like F sharp or Erlang. It's a C-like language. If you want to use something that is more Python-like, like this, that is actually also possible, not in a language itself, but there's this tool I wrote many years ago. It's called DMT, Python-like indentation in deep programming language. So you can actually use this style if you prefer. And as far as I know, almost nobody uses that, but maybe, that's it. So the file extension is called d.d, of course, and sometimes you also find something like dy, which is interface files. These are generated automatically. You don't need to worry about them. This might be done for like if you have, let's say, library and it's closed source and you need to have some API defined, or you have your D file is extremely big, so you can then generate DI, which is basically just declarations of types, so you can speed up parsing. But really, D compiler is so fast that you always use D. There's no C and like .h. Everything is in one file, more like very similar to what is in Java. So we'll go back to this later. A compiler also can receive many other files, like object files, assembly files, and so on different languages. So what is it's a reimagination of C++. So Walter Bright, which was the creator of this language, in 2001 it released it to the public. Initially it was a closed source compiler. Eventually it was open. So version pre-1 was in 2001. And I started using it in 2003 or 4. And I just fall in love, and I still use it to this day. So it's a reimagination of C++ to make a language that is simpler and has different approaches to everything. Modules, templates, compile time, speed of compilation, memory management, arrays, and many more, like strings, UTF, for loops, mixins, and so on. Of course, it's also inspired with many by other languages like C++, as I mentioned, C#, Python, Java, but Java doesn't have too many special things on itself. And later in like not just 2.0, but like in some versions, there are some library facilities that are not in language itself, but in library, that are influenced by some other languages like Go and Erlang are interesting for concurrency and message passing. There are some library facilities for that. But also, if you have some languages that you do some special things in the language, indeed you can implement this probably in library and have it very, very well integrated thanks to metaprogramming, mixins, and also operator overloading, and many other things like dynamic dispatch. So if you have some interesting feature from like language like Julia or Odin, or maybe Go, or some specialized languages, you can probably implement this in D in a day. So, and you code it for 20 years. So that is very, very cool. The language has a very long history. As I mentioned, it was created by Walter Bright from a Digital Mars company. This company was a part of, I think, they were developing C++ compilers. So he was a first author of a C++ compiler in the 80s. So before his compiler, which was, I think, called DC, maybe DC, or Digital Mars C. The C++ compilers were compiling from C++ to C, and they were limited. So this Walter Bright guy actually wrote the first real C++ compiler, and then it was pretty powerful before the GCC and other took also. So these days are not really, people don't use that compiler too much. It's still pretty good. It implements quite a bit of standard. The development stopped for the C++ compiler a long time ago, but it was pretty good compiler, pretty well optimizing and pretty fast. So he knows his compiler theory and compiler and language design things. So he was fed up with C++ design and designed the D. In 2001 it was released. in 2000, at some point there was a version 1.0. I think around when the version 2.0 was released in 2007, it was also 1.0 was released as a stable version, and version 2.0 removed some features from the language that were, experimental and so on. But language is still evolving. We have good things and bad things, and also plans what to do. There's a bit bigger commitment for long-term compatibility. In the past, this was not the case. Sometimes your code will work, but sometimes will break. Some minor detail of the language or library will change, and your code will not work. Now, I was complaining this to the community for a long time, but now they understand that it is important. So something like commitment of Go, for example, for compatibility, that's a huge benefit. So D will not be removing features, even if it's deprecated. It will not be removed from a language. It will be there for a very long time to allow people to migrate easily. There were always deprecation periods, but this takes time. There's still many things in the works, so it's not finished language. Language itself is close to being finished. There's still some features in a core language that are changing and maybe adding, but the majority of the things are improving libraries and performance of the compiler. So on compilations is faster. It's very fast compiler, but it needs to be faster even. Because when it was 10 years ago, it was better, and now it's slower. So now it's objective to make it a bit faster again. Releases are pretty frequent. Our community is very active. There's people who work full-time on it. Releases are about every month or two. Currently, a version 2.106, and yeah, there's some companies use it. It's not super popular, but I wouldn't say it's niche either. There are some professionals using it, some products, commercial products, hobby products using it, and a lot of libraries and tools and so on. Still, of course, there's more to done, and I think this video might help spread the word and attract more people. On a note, a little bit of a PS, if you know C++, especially modern C++, like C++ 13, 11, 14, 17, 20, you might think, oh, now C++ is pretty decent language. Most of these features were actually implemented in D first, and so D got them first. Like, you can say experimental, but I think C++ people don't want to admit it, but D got a lot of things right, and now C++ is catching up actually to D. So if the C++ was like it was in 2001 and D was like it was in 2001, then D would be light years ahead of C++. But now C++ added a lot of features that were in D. So now it's only a little bit ahead. I would say D is still a lot of ahead because C++ has a lot of craft. So I would say easily there's like 50 major features in modern C++ that are I wouldn't say stolen, but just inspired and from D and looked into D. They will usually not tell you that it is from D, but it is. So things like module systems, some string literals, some operators, some templates stuff, some static asserts, const expr, of course, lambdas, custom literals, literal delimiters. What else? Static asserts, const eval. Constraints. There are a few more other things. It still doesn't make C++ as good as did. It's just still very contrived. In C++, in D, you can do the same thing that you can do in C++ in 10, 20 lines in one line. And there are even things that C++ cannot do. There are like two things that C++ just cannot do. And D, it is like trivial, one line. You don't usually need that to use these things, but yeah, it is there. There's some other major languages influenced by D. Zig, for example, its comp time features. Odin, which has, for example, it's mostly influenced by Zig and Go and a little bit of Python. But, for example, its constraint system is heavily influenced by D. I think maybe D, maybe Erlang, yeah, but I think D. Circle, yeah, which is like a C++ next, also of course, and possibly more. Now it is open source, and all these languages flow on the internet. So yeah, let's go to some coding. This is because I still didn't tell you why this language is so good. So let's start with something simple, and we'll go through all the workflow. I have tools installed, so I have a GDC compiler, one of the compilers. I also have a DMD compiler, and also LDC compiler. So these are three major compilers. DMD is official, which is a shortcut for digital Mars D compiler. This is where all the work is happening. So it has a custom backend for AMD 64, x86, and ARM on Windows, Linux, macOS, and FreeBSD. Initially, it was only like this, you know, in 2000, very early, but then things expanded and got better. It has custom backend for generating, optimizing the code, and also emitting the bytecode, sorry, bytecode, the binary files, the machine code, linking, and so on. It's using this digital Mars C compiler also internally. Now actually DMD and other languages, other compilers actually have a built-in C compiler inside of it, of the D compiler, which we'll go in maybe some other video why it is cool. It's a pretty new feature. So DMD, the GDC is just a GNU decompiler. Just like you have a GCC, G++, then there's a GDC, and it is official GNU project. When you go to the GCC GNU.org, right? GNU.org. The very first thing it will tell you that it's a compiler collection of C, C++, Fortran, D, Ada, Go, and D. So it's official port. And then there's also LDC, which is based on LLVM. So the DMD is like most up to date. Usually, the GDC and the LDC takes few months to get to the latest frontend, a version of the standard and library, which is just backporting some things. And then GDC and LDC, GDC you can run on many different architectures, including some esoteric ones, and LDC has also pretty good speed. Yeah, so in terms of compilation speed, DMD is usually the fastest, and probably LDC, then GDC. If you want the highest performance, yeah, you probably want one of these guys. It all depends on your code. You can easily achieve a C++ level of performance, or even have it bigger. So we'll be using one of these compilers. They are pretty similar to any other compiler. There's also some build and packaging tools. We'll not be talking today about them too much. You can use a standard workflow, like from command line or an editor. Use a makefile or not. Use Bazel. You can use dab. It's pretty standard. So we'll do something simpler. We'll do import std, which is entire standard library will be imported. We'll do mine, and let's do write hello world. Okay, that should be a valid program. And let's compile it. I usually use a GDC. So let's do that. Okay, and run it. Hello world, no issues. Standard GCC flags work, so you can do some flags and here and there. You should, if you know GCC and G++, you should be familiar. This is all the same. And by default, it is dynamically linked to a runtime library. Yeah, and binary is probably not super small, but it's actually pretty small, 32 kilobytes. That's actually very good. And as you have seen, even with the optimizations enabled, that was half a second to compile this. And without that, it's even faster. And if you use maybe something like faster linker, that will be a little bit faster, yeah. The primary reason is we actually are importing a lot of modules. We import entire standard library. So if you do something like, hey, show me all the imports that it's importing about 1,000 files. So that is not great. Let's make it faster. Let's import only one function and one module. So maybe that will be better. Let's see. So now I specified a little bit more specific module or package, and also one function only. This actually is specifying that to import only one symbol from it doesn't actually speed up anything, because it still needs to be parsed, and because we are only using this function write ln, that only that function will be compiled. So this selective import is mostly to prevent you from accidentally importing all the symbols and them clashing with your other symbols, possibly from other libraries or your local symbols. If the stdio library has a new function in the future, it might accidentally clash with your symbol. It's usually not a problem because of how the name resolution works in D, but this is the safest way to ensure everything works fine. So let's see how it compiles now in terms of how it shows up. Yeah, 174 seconds. That's not too bad. And we still import a lot of things. So the binary size should be still the same, 29 kilobytes. How we can make it even smaller? Let's interact with the C directly and will not import the standard library at all. So we'll do extern C. We'll do printf, which is something like char star format and then some parameters, right? This is like a C style variadic. So let's try that. We'll do just printf. I guess ptr. I guess. Let's see. No. Maybe I need const somewhere. Yeah, 70 milliseconds to compile it. So not too bad. Yeah, this is mostly to show that compilation can be pretty fast. Actually, compiling like entire standard library is like few seconds. So and it's thousands or millions of lines of code. So it can be pretty good. It can be also parallelized. So let's go back to the standard library and some features, right? I will not explain why I need this PTR and so on. Maybe later. So let's import back entire stdio and do some more hello world. So we can change this signature to be a bit more useful for our testing, and we'll do hello world, and maybe we'll do some standard things like D, and we'll add A plus B, and A will be args1 and B will be args2. Okay, for now we'll do something like this, and then we'll say if args length is less than 3, then return 1 and something like this. So you get some flavor of the syntax, how things could be done. Maybe usage AB. Okay, we don't need this n because ln means write with format and a new line to a standard output. Okay, that looks like a correct code to me. Is no property length, length. Okay. Okay, and it has exception. So that was not detected at the compile time, but it threw an exception with the stack trace. So let's use some features. Yeah, of course, there is a problem here. So what if I make it a template instantiation like this? Let's see if I compile it. Oh, it fails at compile time. Orphan format specifier. Oh, okay, that's interesting. So maybe we should be using that. I will of course explain all this later. This exclamation mark. It's basically template instantiation. So now we can be sure that it works, right? And we do 1, 2, it was 1, 2, hello world 12. So these things are variable declarations with initializer. We access the array, we take args1, arg2. As you can see, arrays have length and also indexing. If we try to access something that doesn't exist, let's say C, that will by default throw an exception, array index error. But if we do something like release mode and f no bounds check none or something like that, give bounds check bounds checks off, yeah, sure, then it takes a little longer to compile, and it doesn't actually complain about it, but probably if we run it under debugger with valgrind, it will say that there's some problem with it. It probably didn't do anything special here because compiler optimizer probably removed this. So maybe let's do this and see what happens to actually use that variable. Okay, it didn't complain to me about it. That's interesting, right? Because we removed this bound check, so now it's undefined behavior. Yeah, for example, now it just crashed. But if you compile it in without bounce checks off or in debug mode, it will actually give us exception. Right, so release removes that. Let's remove this mold thingy and also this time. Yeah, let's actually start using the DMD, which is probably a little bit faster. So then it compiles to slightly different format. Yeah, except array index error, and it tells you what was the problem. You can even catch this exception. So there are exceptions. Exception is kind of standard way of dealing with errors. Now the rework of the standard library is trying to maybe change that. The major problem with exceptions are it's hidden a little bit. A lot of optimizations are prohibited because of the code layout. An optimizer is not really smart about it until you're like LLVM or something like that. And also memory allocation might be required during exception throw. So that prevents using exception handling for error handling and communication in a code that requires no garbage collector. So now there's a evolution of the library to maybe not use exceptions or provide the ability to use exception without memory allocation. Yeah, so this is not a language feature, right? Only things like this in the array indexing is like implicit, can happen implicitly. All the other exceptions need to be thrown explicitly. So this is up to the library designer and programming language users to decide how they want to deal with these things. A language doesn't enforce you in any way. Okay, so what all happens here is, right? We took some array of strings, we assign them, and then we concatenate them. So concatenation operator for string is this tilde mark. Yeah, because plus might mean 1 plus 2 means 3. No, it's actually tilde. And yeah, and if these entities are no at compile time, it of course it will do it at compile time. Yeah. So that's basic thing. Let's do some maybe more. Maybe let's do. Let's see. Let's do this like this. So we'll maybe multiply. So we'll make a small calculator. Okay. Yeah, let's make a calculator. Let's for a start make a calculator that only does multiplication, and then we'll do a times c. Well, we cannot multiply strings, so we need to convert them to integers, right? So let's move this import of stdio inside the main. So this makes an interesting approach. because then we can hide all these imports. So they bring all the symbols like Reitefrun and many others. So by importing them here, or even lower, like this stdconf, we can do even less. Maybe in a scope, right? We hide this implementation detail. This is really useful because if you have a library and you have something like this, let's say you have a function f and function g, and then this one imports foo utils, and this one imports g utils. Because this function will be imported somewhere, right? So this is module f and g. Then we do some import f and g, and then we use f. Then only this import f utils needs to be performed. This doesn't need to be imported, so it saves some symbol parsing and so on. That's a general thing. This can be also done for arguments. Sometimes you can have a situation where you have like a stdi, stdo file, right? You want to accept file type, like a pointer. But that means you need to import this here before. But then it pollutes you. So how you do this? Wait, yeah. There's I think there's a special version of import, which is like this. I think it's actually I think it's actually a template, and you can do it like this. So that doesn't pollute your namespace. I think it's in std, so you still need to import it somewhere. Something like that, probably. Let's actually try that. Maybe not here, but maybe like this. So void is no type. Let's restore this. We don't use this conv yet. Conv will fail here, so let's remove this part here. Let's just prepare it for feature. Let's say 0 there for now. Okay, will this work? Well, not std imported because I named it. Let's rename it so it's shorter. Imp. Okay. Okay, imported not found. Maybe it's called import. Is it import? Expected identifier. Okay. Oh, it's something else. Dlang imported import. Is it a function? Import template. It's kind of like anonymous import. Now I rarely use this feature, but I want to show you. Okay, let's go just to runtime library, and it's probably in std. Or maybe it's in object. Yeah, it's actually import. It's in object. So we don't need to do this. Import it, because this module, this object.d, which is implicitly imported into every program. You can disable this if you don't want, but here there will be like some system things, the base class for all the objects with some stuff, and definition of interface, type, and some typing information. Not a lot. There are like some memory stuff and things like that. You can actually re-implement it or do whatever. Okay, let's see if this works. Yeah. So yeah, you can import it into like argument, or if you have the return type, right? Let's say, and we do a function that does nothing. Yeah, that will work. So that's a way to import anonymously. Anyway, let's go back to our example and this conversion. We'll do loops and templates a bit later. let's convert this a and b to something. So here we'll do args0 and args1, and then we'll do a times b. So a will do, I guess, 2 integer from a, from args0, args1, and b. So we don't need this anymore here. And it was 1 and 2. Okay. Examples are silly, but we need to do something simple. Okay, let's compile this and run it actually. So we have this feature called run, which we can call. And then if I pass 1, 2, I guess, yeah, it's 2. And what about 7 times 7? That should be 49. Excellent. So we haven't made a small calculator. Let's make it smarter. Let's also allow us to have result, and then op, maybe. Something like this. Op, space. I'm confused. You can do this differently, of course. You can do maybe like this. So instead of this concatenation operators, we'll just do this. There's no string interpolation right now in the language. There is a proposal and actually experimental code already. So you could do probably something like args1 or something like that. But it changes other things. It will be you cannot use write fn for this and so on, because it needs to fit into language. Op. So we need to have some results. So let's recreate a result. That will be int, and let's make it not initialized. By default, it will be initialized to 0, but let's not. And now let's take this to be a little bit more in order. So it will be a op b. So op is args2, right? I'm using all this type inference here. You can say string, sure, but let's do args2. Result, because switch is a statement, not an expression, so we kind of need to do it. Then we'll do switch. So case, if it's plus, then the result is a plus b, and then break, of course. If it's multiply, then we'll multiply, and if it's let's say this or this, we'll assert false, not implemented, and we'll say op, not implemented, and then also do default, and we'll also do assert 0 here. Yeah, we don't need this default, but of course we kind of want. So let's see what happens. Run. That should break now. Okay, I was using too much Python. False is normal, so that will not work. Index out of bound, because we need to modify this. Okay, we need op, so let's do multiply. Okay, conv exceptions, unexpected are when converting from type string. Okay, why is that? Unexpected are when converting from type string to type int. Okay, so let's do some debugging, and let's do write fun. Let's print this entire array. Okay, we can do that. Okay, yeah. This looks wrong. What if I do like this? So this looks like corrupted somehow to me. Isn't it not? Is it not corrupted? It looks pretty weird. And then it complains unexpected R, which is this part here. I think DMD has some issues here. Let's say what about GDC, GDM, which is a wrapper for GDC. Okay, I don't understand why it is doing this weird arcs. This looks like a bug. Maybe I need something like this. No? Okay, let's just compile it and then run it. So there might be some edge cases here and there. Okay, now it works. So 7 times 7. Okay, unexpected R. Oh, I see, because this is a star. This is not a bug. This is not a bug. I'm silly. We need to quote star, because in Bash star means all the files. Okay, 49, excellent. But we went through a little bit of debugging and seeing what's going on, right? For example, we can pass complex types to this write-ln function, and it will understand the type information to format it. Okay, 49, and then plus, it'll be 14, I guess, and then division will be some exception, assertion error, not implemented. And then if we do something else, like this, it will say something else, that this is assertion failure on 21. If you do switches on strings, that's one option. As you can see, we can also do multiple cases in a line, and you can repeat them because the break is required. You can also do go to, so we can say go to plus case. So like assume that this case is the same as the other one. If you have enum and enum has some values, you can do final switch, which will enforce you to list all the enumerations of enum. Additionally, for integers, like say a, you can say, let's do something like power, or maybe no, I don't know actually what I want. If it's an integer, I believe you can actually do say something like this, 0, right? But you can do also ranges, so from 0 to 5, and from 9 to 99, and then also 103, 105. So you can do things like that, and it will optimize it and make it nice. So yeah, so these are strings and switch over strings, pretty nice. Let's do some maybe meta programming. So let's do alias t equals int. So this will be a type we were working on. So maybe something like this. And because now it's not an integer, we'll try to say s here. Maybe it will work. Well, if it doesn't work, we'll figure out the way to do it to make it work. Okay. So now we still use integer here, right? So that should still work. Okay, let's fix this up here. Okay, it works. So let's do a little bit more. Let's remove this void here, and we'll just do an inline function of some sort. Let's say we can do, there are many ways of doing this. You can do something like this. I usually like to do maybe delegate, and to be without arguments, and to be returning t, I guess. So maybe like this, and then we'll just call it. Okay. Let me explain why. And also beyond the introducing you, now we can make it const, and maybe it will work now. Like this. So we can just do return AB. We don't need this break anymore. Okay, and this should not reach. This should be not reach here. So let's do assert 0. Let's see if this compiles. Yep, it compiles. So now, as you can see, we just move this to an anonymous function. If you want, you can move it somewhere else, but we implicitly capture this op and A and B, and that kind of works. That's really nice. And allow us to make this const t. So we don't need to specify this t anymore there, because we can infer it from expression. And next step, let's make it a float and see what happens. Okay. Okay, nothing special. Let's do this. Bingo, it works. And we have a pretty generic code. What if we want to add something more complex? Do we have a complex type? I think we do. Not sure if they are still supported. Maybe they are. Yeah. Where was it? Plus. Yeah, it doesn't like it because it's deprecated. And this one doesn't support it. So that's not nice. The complex numbers are deprecated. Not sure. I don't think this function called to ever supported complex numbers. I will check that. So maybe that was not a great example. What about if we do string? So t will be actually a string. Okay, we cannot add strings. We cannot do a plus b. We also cannot do multiplication here for strings. Yeah, of course. So that's nice that it detects this problem. What if we switch it to some small number like byte or unsigned byte? Yeah, cannot convert of type into byte. Okay, because here we for bytes we are implicitly widening the type for this operation. So we'll do cast. Okay, so casts are like this. It's a special operator. Okay, we cannot convert floats. Yeah, so let's go back to numbers. Now let's try bigger numbers. And we have overflow, exactly as you would expect in a byte, right? So that kind of works. You can do things like that. Not too bad, not too bad. So what else we can do? Maybe let's create a function that is a template. So operate, and it will return some type. So we'll call this auto operate. So we'll call it evaluate maybe. Eval, and we'll have what it will have. It will have. We don't know what will be the return type, but so we'll make it a option to know. Then we'll make AB and op. AB and op. So TA, TB, and string op. No, actually, all those strings. Okay, and we'll move this code here to a function. You see, we'll just move this, including this import, and return result. Of course, we can change this. Let's run a formatter on this. Let's see if this the FMT if this works decently. I have it somewhere, or maybe I don't. Okay, maybe I don't. But you can. There are tools to automatically reformat. Okay, so that looks pretty okay. And then we have result. Maybe const. We don't need this indent anymore. Maybe eval, yeah, eval, and we need to tell it in what types we want. Let's do floats. Well, let's use this t, and there will be args1, args3, and op. And op we kind of need still here. So let's make it somehow differently named, so there is no conflict. Op will be provided to us, so let's make it here. Yeah, that should work. Okay, let's try. Arg, not arg, but args. Of course, you can name it whatever you want, you know, like this. It's just a name. Let's use this plus because it's better. Okay. Okay, unexpected when converting, and if we switch it to float, now it works. Okay, excellent. So let's do some looping, maybe. Let's do some looping, so we can have like repeated operations. Okay, something like this. So we'll do 4 subargs. For each I, from 1 to, because 1 is kind of the first argument here. Arg's length. But not exactly arg's length. We need to like do every third. Let's divide it by 3 and see. I don't know if there's like a for each with step. Is there a for each with step in D? I don't think so. So we'll look into materials later. So it will be in statements. For each over integers, I guess. For each statements. For each aggregate expression, yeah. I don't think it's expression because this is not an expression technically. This is some kind of weirdness. Over arrays, characters, associative arrays, structs with classes, yes. These are advanced features. With step. Well, let's use there is a library for that, I'm sure. So maybe something like iota. Range, sure. Is there iota? Please tell me there is. Yes, there is. Okay, so we'll use that feature. If it's something simple, you can just do this or maybe this. The problem is we need to do something a little bit more complicated, so we'll do iota. Iota, and beginning will be 1, and end will be arg's length, and we'll do 3. Maybe it will work, maybe not. So it will be I plus 1, and this will be I, and I plus 2, I plus 2, maybe. We need to import this iota, so let's do import range, iota. Oh, let's import everything. And let's see if it still works. Yes, and now we can do another one. So 5 plus 9, 14. Yeah, excellent. So let's remove this eval, something like that. Simple for each. Okay, and 9 times times 9. Okay, yeah. So maybe it would be nice to not write this as args op thingy. So like maybe like 1 plus 5 as a single argument would be nice. So let's maybe do that. So now we need to convert it to 2. Instead, then args we can do 1 by 1. So instead of iota, we'll just do arg, and it'd be, we don't even need I, we don't care. So with args, and we want to skip arg 0. So we'll go from the first one to the end, which is like this. I think it's implicit, but yeah, we can also use this symbol, which is the equivalent of arg's length. So we are using now slices. Okay, so we now need to do some splitting. So import std, I think we already have it, so let's do split. Out const split s arg split, I guess we want split on space or something like that. Yeah. So as you see, I'm using arg.split, but this is not a method on the arg. this is very fancy feature called universal calling conversion or something like that. Basically, compilers see, is there a method split on arg, which is a type string. I didn't say it here, but it's a string. Is there something like string split, either static or dynamic method, or a field? If it's not, then it will do some other thing. If there is something like dispatch or alias this on a method, it will try that. But if this still doesn't work, it will see, hey, is there any method that can do this? And there is, because in this std range there is function like that, split arg. So let's do split here, split, splitter. Okay, maybe it's not in this module. I mean, I'm pretty sure there is a splitter somewhere. I think we want a string splitter, not array split, range splitter. So I think iteration maybe, split, splitter. Yes, splitter is an option. We can do. It's just a function that gets a range as the first argument. These are template arguments, and this is input. So that is a possibility. What if I do string? So let's go to string, please. Do we have a split here? Split, yeah. It's an std array. So often you don't need to care too much. You can just import everything or something. Maybe it will work. So let's clean this up a little. Some people like to put some spaces here. So now we have this splitted, and this is just okay. So we don't need this argument here. It will just split on white spaces. Okay, you can provide this extra separator, but it is optional. But as you can see, this split method receives one argument, but we provided 0 arguments. Well, because compiler just rewrites this to std array split arg, and it will be the same. So you can imagine, and this is super cool because then you can do some crazy chaining, even if these are not method. And this is pretty cool. I can even create our own function, function mySplit, that gets a string, and we'll do just, I don't know, split s, and we'll call mySplit. Do you see how it works? It will work. It will just do the same lookup. Hey, there is no mySplit a method on arg, but there's a function that can receive a string. So let's see what happens. For each, something is wrong with for each, blah blah blah. Args, I guess args. The I is not defined. Found for each when expecting. Following expression found when expecting. Line 40. What? What's the problem? It's not function. It's just we want some it's a return type, right? And 40. What is in 40? For each. Well, let's make it static. I don't think that's important. Found. It's not dot dot. It's not colon. It's dot dot dot. 3 dots. Maybe 2 dots. Yeah, 2 dots. No I. Yeah, we'll use s for that. And we do assert s length equals 3. Let's see what happens. Okay, no property mySplit for arg of type string, but there is. What if we do static? Okay, this suggests to me this is an error. I? What I? No I? Okay, it works. Not sure why I cannot do arg my split. No property my split for arg. That is really weird. What if I move this outside of the function? Yeah, sure. Now it works. Okay, so this is a bit weird. I didn't know that there's this limitation. It's probably because of lookup rules. Yeah, like otherwise order is mostly independent on the top level. We can put it these helper functions at the bottom maybe. Okay, it's up to you how you do it. It will still compile. Okay, and then we do another one, 9 times 9. Okay, and then if we have a space, it still works. If we have more spaces, it still works. And we have another there. That should be assertion failure because not enough arguments there. So let's say here we'll say something about this. Can we do format strings there? Let me think. Expected three elements got D. Maybe. It's a stretch. It's a stretch that it will work or not. Okay, it doesn't. So you can do something maybe like 2 int s length. What about now? Incompatible, because it's not to int, it's to string. Okay, got 4. Okay, so we can do something like that. Yeah, you can do assert. Asserts in a release mode will be removed. So this is actually a user error, so it should not be removed. It should be always there. So if it's not 3, then we'll raise some exception. Throw new exception. Okay. Excellent, exception. So what else we can do? Let's try to making this no garbage collected code. So we'll do no garbage collection and see if this will work. Probably not because of this operator here, but let's see what happens. Yeah, cannot call non-GC function conf2, so that's not great. So unfortunately, a lot of standard libraries are, yeah, not GC friendly. But we can do something maybe like this. Maybe like no GC, maybe this block. That maybe will work. I'm not sure because technically the delegate can be GC. Maybe like this. Maybe like this. I rarely do these things. Okay, you do it differently. You do it here. Okay, and I cannot do it like this because I need the result. Okay, cannot use operator or yeah append in NoGC because that allocates memory. So, but you can try these things, and if you try, you can find all this usage. So yeah, you cannot use appender. Yeah, but there's, for example, lazy split or splitter, which is iterator and doesn't allocate. Yeah, so these are interesting things for sure. Yeah, we didn't talk much about templates. So let's make this my split a template. So instead of receiving a string, let me make it receives any type. Okay, so any type, you know, maybe even 2 types or something like that. Yeah. So let's give it another type, which is G, and it will be some other variable that we don't use for anything. Now we need to pass some extra thingy here, so let's do space. So G will be inferred to be string too. Okay, as you can see, arg is a first argument, this S, and extra arguments will be here, right? G and maybe H and so on. There are also varargs. You can do dot, so which means variable number of G's. You can also do dot without type. That means unspecified types. and many other things. So the return type we still don't specify. We'll compile. Yes, it still compiles. Yeah, 81. And what would be the return type here? We can make it a bit more specific, maybe. It's going to be array of t, I guess. Yeah. So if we do some mistake here, like array of int, that should not compile, cannot implicitly convert. But most of the time, you can just say auto. It is nice to sometimes specify the type a little bit more specifically for documentation purposes, because here you can say, you know, the split is of this type, but this other one says auto. So like, what is the return type? That is not great. So I hope maybe documentation could be improved here, but then it's also not clear, because auto is actually then very complex type. It's actually a range of type of elements that are elements of range, but it is not the same type as range. It's anonymous type. So it actually probably cannot be even named. It's pretty complicated, yeah. So this type sometimes cannot be named, but here you can see element. It's element type, and so on. Yeah, what else we can do? Maybe some classes quickly, right? So this is something I would do like this, but maybe let's create a custom type with operator overloading. My type. It will be just float, I guess. Float f x, and we need to have a constructor, maybe. Should we? It will not work with this conv, so but we'll change that. So maybe we'll have a constructor from string, and then import stdconf. You see, I'm limiting this import here. We'll do x equals to float s, sure. And then we need some operations, maybe like to string. There's many ways to do this. One of this like this. Return to string, I guess. X. We need to import it again. Because we are importing it multiple times, let's import it here a little higher. We can do that. So this is not the only way to do this to-string conversion. There are other ways that does not require allocation. Like there's this int write to and so on. We'll not deal with this right now. There are ways. You don't need this semicolon here compared to C++. And maybe it's not a good idea to have a class we want value semantic, so we'll use struct. So structs are value semantic and class are reference semantic. So let's do that. And we need some operators, right? Like plus, minus, so on. So let's do auto, op binary. Okay, there'll be a template with a string s, and then another value, other. Okay. We can do constant here. It will be passed by reference. And what we need to do? We need to so we can do something like this. If s is plus, then return, of course, x plus other x, right? All the fields are public by default. Yeah. So we can do something like this. Yeah. So let's do that quickly and see what happens. Maybe it will work. I did not test any of this. Incompatible types. Both parents are of type const. Okay, sure. I think that this also needs to be const, maybe. Also, this can be const because we want value semantic. Will this work? Incompatible types. Operator is not defined for a of type const my type. Why? Is it not? Op binary. Op binary. What? Well, how is it not working? Binary? Operator? Oh, it's op binary. Yeah, my bad. Okay. We cannot cast expression of type float to my type. Float to my type. Oh yeah, because it is float now. Sure. We need to wrap this float. This is a float, so we need to wrap it. So we want this. Because in this eval, we probably expect this to be of the same return type, something, something. Yeah, because of this cast here. Yeah. Constructor is not callable using const float. Yeah, because now we do this differently. We'll just construct it using constructor. It's not callable using const float. What? Where do we have float still? Oh, because it's okay, my bad, because this is not a string anymore. So we need also a constructor with the float. Okay, so we will just say x equals x, and here we'll just delegate to the constructor. Okay, and you might be wondering, but this field is const. How we are assigning to it? Yeah, you can in constructor. You can. Okay, it still works perfectly. This one doesn't work. 9 times 9 is 18. It should be 81. So we did some boo-boo somewhere. Okay, so it is here. So let's do some unit test that this is for sure like that. So we'll do assert my type 5 times my type 5 is 25. Well, we will need to do a bit more, but we'll just extract this field here. Yeah, something like this. F. We can do something like this maybe. We might implement some op equal or something like that. There are different, or op compare. Yeah, so something like this. We can have this unit test. Let's see if this compiles. Okay, it compiles. So let's make it broken again. Plus, yeah. And run unit test. So how do we run a unit test? I guess unit test. Unit test failed. Excellent. Let's make it fixed one and passed. Okay, great. So let's make it now do something smarter with this op binary, because like this is very repetitive code, and as you can see, this is s. This s is actually a string. It's one of these operators that we pass. So let's make this code generic, so it supports all the operators. How will we do that? But like, you know, here, okay, there are a few options, right? We can do something like static if s equals plus, then do this. Else static if s equals something else, then do something else, right? And else maybe static assert, not supported. Yeah, and that should still work. Yeah, maybe just fix this. Found when expecting. What? Static if return. Found if when expecting semicolon. And that should work totally. Expression static if, yes. Okay. What if we try to do division, implement the division, or minus? Okay, assert false is false. Okay, so what was this? Not implemented op binary, and then it will say here s. Not implemented op binary minus. Yeah, because we did not implement it. So another case. Okay, let's do better. We'll use some metaprogramming features, and you'll be delighted. So we can leave this return my type. This will be common. But here we need to do something else. So let's do mixing a string. So we'll basically form an an expression using strings and do mixing. All right, let's see if this works. No way, it works. So what is going on? So this mixin is evaluated at compile time, and I will show you what it does. Pragma message like this. Right? It will perform these three operations. This is a resulting string. And we are just using mixin to do some expression. So if I have this, it is this, yes. So this is mixing expression, and then we're just passing to this expression x to there. We can technically probably do also this differently. We can do make it like this, right? Because the lookup will be performed. It's still expression, and we are looking local lookup. So this x and everything works. Okay, what is the problem? Blah blah blah. Yeah, one more like this. Still works. What about we make it not a expression but a statement? Can this work? We need semicolon there. Of course it works. Can it be more than one expression here? Maybe. So something like a equals o equals order x, and then o. Yeah, maybe. Can we do this? Of course you can. So these are some interesting things I wanted to show, and there is so much more. Operate like mixins are really powerful. For example, this doesn't need to be like a string. It can be some function that gets some parameters. Let's say we'll call it order. We'll call it x and order x, and this can be some function, I guess. Let's make it static f, and there'll be string a and string b, and it will return string, but we'll use this, and yeah, we'll do this. We don't know what is now. We have now more parameters, so maybe s also. Sure. So be a and b and close, and we'll just return the string. How about this? Huh? And maybe we'll just make it an express like this, so it's a little bit less. There's many ways you can do these things. Okay. Will this work? I guess so. Comma, semicolon there, and this is expression. So without this, do we need this? We don't need this. So let's just do this. Yeah. Just concatenate these three things. Okay, not known. Okay, sure. We'll call it op. Yeah, it's good. It's good enough. Anyway, that is long enough. As you can see, it's very powerful. You can do a lot of things, of course, standard stuff like recursion, classes, interfaces, template, modules. So many things, arrays, slicing, strings. But this is just like a little bit of taste what can be done, right? It's very nice, very fast compilation cycles. So the homepage is dlang.org. It's pretty simple. Has a download options for different operating system. There's a changelog. There are other downloads, 3 compilers. You can start with DMD. If you're on Linux, you can use GDC, which is pre-packaged into multiple distributions. LDC is also pretty nice. All the packages, check on your distribution first, then try here if you're on Windows or Mac. There's a forum, you can check it out. The language reference is excellent, it's pretty good. A library reference is also pretty good. Then you have packages, which is this dub package manager, which is de facto standard package manager. You should also check the forum. Forums are pretty good. And dub I already mentioned. There are some IDE tools like DFMT for formatting. There's DMT for using it more like Python. What else? That is mostly it. You can also find a lot of community stuff here. For example, there's a wiki, there's a Discord apparently, IRC. Yeah, IRC is pretty active with developers. Resources are pretty good. There's some books you can buy or find online for free. There's a tour, so if you don't want to install, you can just play and click run here, and it will run for you. So you can explore things. It's pretty good. IDE, which is lists all different plugins and IDEs, including Visual Code, Code, Dext, Code Blocks, and a few others, and there are many others. As you see, I was using my favorite editor, which is very simple, just editing, and it has pretty good syntax highlighting, as you can see, that I wrote like 15 years ago. Still works. And yeah, I hope that is a start of some kind of series. If you'd like to have something specific, maybe go to comments and post it. I will try to answer or make another video, or maybe go to New Users Learn or General. If you have a little bit more knowledge about D and other languages, then you can go there. It doesn't require any login. You can, but you don't need to. And it's pretty interesting. Oh, what's somebody asking? Oh, this is just what we were asking here. That is pretty interesting. Up assign. Yeah, this is wrong. Yeah. Anyway, that was absolutely accidental that somebody was asking about this, but there's many other features in the language. And this is just a list of specification basically for the language itself, not for the library, including interfacing to C, interfacing to C++, portability, and the better C, which is a really awesome feature. Import C, which is also a super nice feature, where you can just import C functions directly, just like include. Unit testing, traits, which are really interesting for runtime, static compile time reflection, which are really cool. There's also a library for this. I didn't touch on enums or interfaces or arrays, associative arrays. I didn't touch template mixing, contract programming, which is a very simple concept. We can have just in and out and other tests on the functions and methods. I didn't touch on live functions, which is a new feature, which is like a Rust borrow checker. I didn't touch on a lot of other things like type qualifiers, like final, lazy, scope, in, out, and so on. I did not touch on properties and postblitz and distractors and literals. There's so many other things. Yeah. I didn't touch much about on exception handling. Yeah, you can. if you are familiar with C, yeah, it would be pretty normal, right? But there might be some other things like delegates and small short circuit expressions. There's a very similar comma expression, just like in C, basically. There's some extra operators like these two guys. This is basically power 2, and this is arithmetic shift, logical shift, sorry. Casts are a little different. You have a ternary operators with side effects if needed, and you have this is operator for pointers, and is not is, and a few more. We also had in different like we had these operators, which usually transform to some operator overload, like op compare. In version 1.0 we had like actually 10 more operators for floating points because of nonce and so on. But yeah, their properties like min, max, and so on. Complement expression, sure. And there's so many things, like including this 0b, yeah, lexical. So you can write something like int I equals 0b 1101 1100 001 It's like bits exploded. You can do these things, and many other things. As I'm saying, it's pretty cool. It's pretty well documented, and pretty smart people are coding in it and developing it. Yeah. That's mostly it. I had this old book on D, but it's in a different language, so I mean not in English, so maybe I will not recommend it unless you're Polish. And that's all for now. I hope you enjoyed. Bye bye.